Hi guys, so this is the first chapter, first section of Algebra 2. It has to deal with graphing quadratic functions in standard form. Okay, so we're going to go through a couple of different forms here when we're talking about graphing in chapter 1. Standard is the first one. So first off, quadratic form, what does that mean? So if something is going to be called a quadratic function, that means it's going to have its highest exponent in relation to a variable of 2. So some examples would be y equals x squared plus 1, okay? The reason this is quadratic is, again, because this exponent being applied to the variable is only a 2. Nothing higher, nothing lower. Or another example would be y equals 5x squared minus 3. Why is this one quadratic? Because of this squared up here. And it, again, has to be in direct relation to that x variable. So when we graph a quadratic function, what does that look like? So what it looks like is this parabola shape. Okay, some people have called this like parabola. I've seen it all, but it's called a parabola. Parabola is this U-shaped function. Okay, it's going to continue up for infinity or down for infinity. You can see many types of parabolas. For the most part, for this section, we're going to see when they open up and when they open down. Okay, standard form. This is when you see anything in the form of y equals ax squared plus bx plus c. This is the longest standard form. This first part today, we're going to work with mostly just this first chunk here. So not this entire thing, but just that first part. But again, that is what standard form is. Okay, I'm going to take my laptop over to this other chair that I have set up to show you some other things that I already have written down to not waste your time. So first off, up at the top, some characteristics of quadratic functions. The first thing is they take this standard form of, again, what we said over there, ax squared plus bx plus c. All of the following are true when we're working with standard form. So if the a is positive, so when we come along with this a is going to turn into a constant. Just like in some of our examples, it might be a 2x squared or 5x squared. But basically, if it's positive, the parabola is going to open up. If that a is, say, a -3, that a is negative, so it's going to open up, not open up, it's going to open down, okay? So our parabolas can take different kind of shapes. They can be these fat, wide ones. They can be super, super skinny and narrow. The reason these two become the way they are is if the absolute value, what does absolute value mean? Again, it's when you take the positive version of a number. So the absolute value of -3 would be +3. If that number is greater than 1, then it's going to be a nice big fat wide one. If it's smaller than 1, meaning any decimal basically, any fraction or decimal, it's going to start to be more of a skinnier one. So the smaller the decimal, the skinnier it is. The larger the number, the fatter it is. Okay, so some things that we use to find the graphs of these quadratic functions in standard form. The first one is the axis of symmetry. Okay, so every single parabola is absolutely symmetrical from one side to the next. So if I put a line straight down a parabola, oh, you can't even see that. If I put a dashed line straight down a parabola and I folded it in half, it would look identical on both sides. Okay, obviously my lovely drawing is not that symmetrical, but they truly are in nature. Put a line straight down the middle, you fold it, it'll be identical. So that's what the axis of symmetry is. You can use this by using this form, x equals -b over 2a. That's how you'll find that x value of the axis of symmetry. Again, this b is coming up from your standard form, okay, the b in standard form. My a is also, let's flash back up there, okay? The b is coming from this b, the a is coming from that a, okay? So you can take those numbers directly from that. So two other things, not only does this formula find us our axis of symmetry, it also finds us the x-coordinate of our vertex. Okay, what's that vertex? Vertex is the very most bottom point, or say that we have one that's actually opening down, it's going to be this very, very top point, okay? So when you're looking at finding the x coordinate of a vertex, you use the same formula. And y-intercept. So the y-intercept is wherever this parabola crosses the y-axis. Okay, the y-axis is the one that goes up and down. So anytime you cross that, it's going to happen at 0, C. Okay, we're going to talk about this a little bit more in depth back over here. But I got to bring you back over with me. Okay, we're going to do two quick examples, and that's it. Okay, I'm going to have you graph something. Like I said, standard form is y equals ax squared plus bx plus c. We're not going to do that whole thing today. We're going to take just this first chunk of it, and we're going to use just things in the form of y equals ax squared, because that's the thing, okay? Sometimes we don't have to use all of standard form for it to be standard form. Sometimes these functions come in shorter versions of that. So given, for an example, given the function y equals 2x squared, I want you to graph the function. Okay, so first thing, when we start to graph quadratic functions, I need to know my starting point. I don't even know where to start with this graph unless I know where that vertex is. Okay, the vertex is the very, very, very middle point. It's either going to be the top or the bottom of that parabola, but I have to know where that is in order to even start graphing this. So we need to find that. If you go back to the notes that we had just kind of done before this, you find the x value of the vertex using x equals negative b over 2a. Okay, again, this is for my vertex. So looking at our function y equals 2x squared, let's write this standard form up above it. ax squared plus bx plus c. We already are seeing that we only have the ax squared version of this. So first I'm going to identify what's my a, what's my b, what's my c. So if we match up our a with our currently given function, I'm seeing that a equals 2. Okay, again, I'm just finding this by matching up what I'm given with what I know about standard form. So this 2 matches up with where that a would be in my standard form, meaning that my a equals 2. Okay, so now I keep going on and there's nothing under my b and there's nothing under my c, right? I don't have that part of my function. When I don't have something, it means it doesn't exist. When it doesn't exist, it can only be 0. So my b would be 0 and my c would be 0. So now why does that make sense? Well, let's think about it. If I'm adding on nothing, okay, I'm not adding on anything to this 2x squared. That means I can only be adding on 0. If it was a half, I'd be adding on something. If it was 500, I'd be adding on something. So adding on 0 is the same thing as adding on nothing here. Okay, so when that variable does not exist, it means that that number actually is representative of 0. So when I use these to go ahead and find my vertex, I'm seeing that x equals negative b, okay? That's negative 0 over 2a, okay? So I take, every time, it's going to be 2 times whatever my a value is. My a value right now is 2. So my very first thought here is, well, no matter what, I'm going to have a 0 in my numerator, right? Top of my fraction is my numerator. That's always a 0. 0 divided by anything is always going to be 0. So I can see right off the bat the x coordinate of my vertex. Remember, when we're talking any coordinate points, we have an x and a y, okay? So I know that my x value is 0. So I challenge you to think, then how do I find my y value from that? If at any point in time you're given an x value, you can find the y value by plugging your known x value back into your original equation, okay? So to find y, now I'm going to take my original equation of y equals 2, but again, I know my current x value. My x, instead of putting 2x, I'm going to put 0, right? That's my current x value. So 2 times 0 squared. Now, if you know much of anything about math, okay, when we're taking 0 squared times 2, that's always going to bring me back to y equals 0, okay? 0 to any power will always be 0. 2 times 0 gives me 0. So my vertex coordinates are, in fact, 0, 0. What does this mean for a graph? Okay, let's start plotting this out. Okay, so there's my coordinate plane. My vertex is always that very top or very bottom point. My vertex is at 0, 0. That means I'm dead in the center. That's my first point. Now, something I challenge you to remember from before. We referenced our a value to know whether or not this parabola opened up or opened down. Okay? So if the a value was positive, we opened up. If it was negative, we opened down. My a value is in fact positive. Okay? That's a positive, so I know this parabola is going to open up like a U shape. How do I find the rest of the points though? Okay? Generally, we'd go about this by saying, okay, now I want to know what my y-intercept is. Okay, that's that point that crosses my y-axis. How do I find that? Generally, okay, to find y-intercept would be the next step. And you do that by using the formula 0c. Now you can't see that marker very well. Okay, 0c. So the 0 always stays. This is the easiest one to find by far. Our c value we already identified was 0. So, oops, the only place we cross the y-axis is 0, 0. That was our vertex. So these are the same point. Our y-intercept is also our vertex in this case. So after I find my vertex and my y-intercept, from here, I just have to start plotting points, okay? You can choose any points you want. My advice on choosing points would be you choose ones that are near your vertex, okay? So when I go to start my XY table, I already have 0, 0, right? That was kind of already given to me. Not given to me, but I already found that one. Okay, so, oopsie. There we go. Okay. So I already have the point 0, 0. My advice is going to be, let's try to just go out a little bit. I don't need to know like what's happening way out here yet because I don't even know if my parabola exists out there. So I want to try to start small. So let's hang around these 2 points right here, okay? Let's maybe try figuring out what happens when x equals -1. And on the other side, maybe what happens when x equals 1. And then let's just maybe try one other step out. What happens when x equals 2? and what happens when x equals -2. Could I have chose 3 and -3 or 4 and -4? Absolutely. I can choose whatever numbers I want. My advice to you is just to stay very close to this vertex at first and then keep going out from there. So what do we do when we have an x value and we want to know the corresponding y value? You just plug it in, right? You plug it back into the original equation. So using this y equals 2x squared every single time, in order to find what happens when x equals -1, I'm going to say y equals 2 times -1 squared, okay? And I go ahead and I figure out that number. When I want to find when x equals 1, same thing, y equals 2 times 1 squared. And I just keep going, right? For 2, it's y equals 2 times 2 squared, okay? So you're going to start filling this in. What we're starting to see happen is -1 squared is +1, right? You square a negative, it turns positive. -1 squared, +1, 2 times +1 is 2. So when x is -1, my y is +2. Same thing for +1. 1 squared is 1 times 2 is 2, okay? So then when we're dealing with 2, you should be getting 8. When you're dealing with -2, you should be getting 8. I'm going to continue my graph by plotting these points. -1, 2 is my next coordinate point. So I go over -1 up 2, okay? Then I'm going to go with my other one, +1, 2. So over 1 up 2. Okay, remember you always plot x-axis first, then y-axis. 2, 8 over 2 up 8's probably way up here. Same thing, over -2 up 8. So what I'm going to say is these points are enough for me to make the conclusion that I can connect my dots to make this parabola. Okay. So let's review all the steps that we've taken. The first thing we did was we found our vertex using this formula. We plugged our x value we found into our original equation to get our y value, okay? Then after we found and plotted that vertex, we came over and then we found our y-intercept using the formula 0c. We found that was 0, 0. That didn't give us any new points, but it usually will. After finding that, that's when you say, okay, we're done with our formulas. Let's go ahead and start making our table, okay? Just this XY table. We educatedly guessed what kind of points we should have chosen. Everyone's XY table can look different. My advice to you is that I shouldn't have chosen a point way out here because you can see how quickly these numbers are getting large. If I would have chose something like maybe -5 or -6, that point's going to be way up here at like 50 or something like that. Okay, I don't want points that large. I want to just find out where the smallest points are happening to show me what my graph is doing. And then I just get to throw in my arrows and say, it'll keep going up after that. Okay, that is all for this video. I'm not sure how long this one ended up being, but I promise you I'm going to get better at these. My goal is to always have my videos be like 10 to 15 minutes max. We'll see when I hang up on this if I made that goal. If I didn't, I'm so sorry. I'm trying to make these as short as possible, but still give you like the best explanation I possibly can. I'll get better, okay? I promise I'll keep working on it. I'm trying to make these short and concise so that you don't have to listen to my voice for 50 minutes at a time. I will post the corresponding homework assignment that goes along with this. Make sure you watch the video first. I advise you to be taking notes as you go along with these. It'll be good to look back on at any other time when we're taking a test or the final, just in case you need to look back while you're doing your homework, that kind of thing. Then you don't have to watch my video again. Let me know if you have any questions for remote learners. Make sure you're doing this assignment, turning it in by the due date, contacting me if you have any questions. For in-person learners, make sure you're not doing the assignment until you come to class, okay? We're watching the video at night and coming back in class to do the assignment. So the assignment will be posted for the remote learners. But in person, please don't do the assignment. You're gonna have all of class time to do it. Okay, this is my first video I've made so far this year. I'm sure it was cringy. I'm sorry. Yeah, I hope it was okay. Let me figure out how to turn this off now. Okay, bye. Oh gosh, bye.